All right, so let me get my problem out that I wanted to do with you. So this is probably, if I'm doing it with you, there's probably a good chance you're going to see it. Whoa, sorry about that. On Thursday. Yeah.
So we can have an option with the way we can solve the problems, or is it going to be like, can you solve them the way you want, or no?
Like, what do you mean?
Like this way, or like the you know, the one that's like plus minus, the plus and minus sign.
Like when you're giving the answer or when you're solving it?
No, we're solving it.
Like the rational root way? When you have to do the plus minus with the list?
Yeah.
If I want you to do it that way, you have to do it that way. It'll say it in the directions. If it doesn't say it, you can do it every way, please, but I think they give specific directions. Okay, so we have some problem sets, and I'll put the answer keys up. One's up there, and I'll put the other one up right after this. It's on my other computer. So it might be something I look over. Now, in our first problem set, it was some of the last questions. I forget which specific numbers they were, but it gave an example like this, and there was a few in there as well, so you might want to use those. Suppose, we have this polynomial 5x squared minus ax squared plus 45x minus 37. And when we, leaves a remainder of -1 when divided by. Sorry, I'm just trying to write it kind of how you'll see it tomorrow. By x minus 4, find a. So we had done a few of these. They were in that first problem set. It was numbers, I don't know what it was, but I had that problem set somewhere today. It was numbers 78 and 79 on polynomials problem set 1. But let's go over, or re-go over, how to do this. So I say, well, okay, I have this polynomial and I know I'm dividing it by something. So let's set that up. I'm going to use synthetic division because it's just a nice linear factor. So I'll put a 4 here, and then I put my coefficients. 5, I would put negative a. Our main goal is to find out what that is. 45 and negative 37. And the other thing I can fill in is there's a remainder of -1. So I know my remainder goes here. So if I just started this like normal, I would say, I can bring this 5 down. I can do 4 times 5 is 20, but then I'm kind of stuck, right? Because it's negative a plus 20, I don't know what it's going to equal, so I'm stuck there. So these are ones that we kind of did, you have to kind of go backwards. So let's think about it. Negative 37 plus what gives me -1?
36.
30, lovely, thank you so much.
Oh, more.
36, right? You just think, okay, well, what would I put there to make it add to -1? Now we're gonna kind of zigzag backwards. If we go this way, we multiply. If we go this way, we divide. So 36 divided by 4 is 9, right? Because 4 times 9 is 36. 45 plus what is 9? Yeah.
The first term in the polynomial, is that squared or is it cubed?
Oh, I'm sorry, it should be cubed. There you go.
No. I'm at 54. Negative 54.
No.
Negative 36?
Yeah, negative 36. Sometimes, these things hurt our brains. Okay, work backwards again. 36 divided by 4 is -9. So the reason we did that is basically this is now a nice little equation that we can solve. So it's more just about, moving things around, maybe doing things a little backwards, things we can do. But they're a little bit different. But now we know that -a plus 20 equals -9, right? Because we're always adding when we go down. So we can do a quick solve for a. -a equals -29. So a would just be 29. And that would be your final answer, because that's what it asked for. But wanted to point that one out to you. Okay? Another thing I wanted to point out, there is, there's like one longer question, it's kind of like it's everything, right? So it'll ask about the rational root theorem, listing your possibilities, actually solving it. And one part of that problem is using Descartes' rule of signs to figure out how many possible answers you have. So let's do a Descartes rule of signs problem. I feel like some people are still a little iffy on that one. Just to kind of check that we understand like what your answer should look like type deal. And then I'll just do a quick check and see if you guys have any other questions, if there's anything, things that you would benefit going over, but I think in general, like we've done 8,000 rational root problems, so if you can do that, you can do Thursday's quiz. Any questions on this before I erase it? Okay. So let's say we're given the polynomial equals plus 3x minus 1. And I say using Descartes' rule of signs, Descartes' rule of signs, I want to know how many positive real solutions could there be and how many negative real solutions. Negative real solutions, I can't help. So I'm just going to write how many positive real solutions. We'll start with that one. Okay, so I always kind of organize myself, okay? For the positive, you just kind of deal with what you got. So think about your signs. The first one is positive. The second term is negative. The third term is positive. The fourth term is negative. We're looking for sign changes. So how many times does the sign change? Well, from a positive to a negative, that's 1. From a negative to a positive, that's 1. From a positive to a negative, that's 1. So there's 3 sign changes. But that's all the work you have to do. That's about as crazy as it gets. So when I say how many positive real solutions are possible, you would say 3. Or you can always subtract an even number off until you get down to where you can't anymore. So if I subtract 2 off of that, or 1 positive real solutions. So if the answer was 7, you would write 7 or 5 or 3 or 1. If the answer was 4, you would write 4 or 2 or 0. So you basically just keep subtracting 2 until you can't subtract anymore because you don't want negatives. But there's not just one answer. You could have more than one possibility. So just as a reminder there.
Wait, why was it 3 or 1? I was writing down all the stuff.
There's 3 sign changes.
Yeah.
So that's 3. That's where the 3 comes from. Or you can take your, whatever the highest one is, and you can subtract 2 until you get down to you can't go anymore. So if I said how many negative real solutions are possible, you have to, this one you have to kind of do a little bit of work. It's more just like thinking in your brain. But when you think about your polynomial, think about plugging in negative x. I kind of just try to do it in my head, but you can feel free to write it out if you want to. So I think in my head, if I plugged in a negative here and I cubed it, a negative times a negative times a negative is a negative, right? So this first term would actually turn negative if I plugged a negative in there. And then I say, okay, well, what if I plugged a negative in here? A negative times negative is positive, but there's a negative with the coefficient, so that would turn it negative. And I say, well, what if I plugged in a negative here? It would just make that negative. And then the last one's negative. Oh, look at that beauty. Are there any sign changes? No, it's all negative. They're all the same. So we would say there are 0 negative real solutions. Don't worry about imaginary solutions. You don't have to do that. So I know we had made a little chart and we had an imaginary. You don't need to worry about it. It's not part of your questions. So just as a heads up there. So that's about as crazy as any Descartes rule of sign problems will get. So just make sure you do know the general idea of what's going on. How many sign changes are there? That's the maximum number of solutions, whether positive or negative. And then do remember you can subtract 2 off of it. Okay, so I wanted to clear that up. Let's see. Secretive thing. So I'll give you kind of an idea, and then we'll just see if there's any other questions on your guys' part. If not, we can maybe just look through and do a few things and maybe take like an extended mass break outside. It's really beautiful looking. Okay, my computer's just going really slow, so give me a second. Still waiting, okay. So reminder, you can use your notes tomorrow, or not, excuse me, Thursday. I'm gonna keep saying tomorrow instead of habit. So it ends up, because I like to go in, knowing what the thing. So I go in and edit everything, and I make it so it should not take you any more than 40 minutes. So the reason being is my block 7 has it, and they only have 40 minutes because of, the bus dismissal, and the last period's always short. So to keep everything fair, everyone will get 40 minutes. And it's definitely doable in like way less than 40 minutes, so just as a heads up. There's 10 problems. 5 of them are multiple choice. So please go into, it always drives me nuts when people do all the multiple choice and then you miss a problem at the end. I would just skip to the ones that are worth more points, personally. If you need to warm up the brain a little bit, that's okay. But there's things like writing polynomials in standard form if you're given zeros. We did a bunch of that yesterday, right? You just write it in factored form and you do a whole bunch of distributing. So you will have 1 or 2 of those. Make sure you know the conjugate theorem. So if you do see a root that is imaginary or is, other word, irrational, that you do include its conjugate. So if you see 7i, you have to have negative 7i, just that type of deal. There's one similar to that first one we did, so that's why I did that one with you, entrance. There's just like one longer problem and it kind of includes everything. So use the rational root theorem, list your possibilities, use Descartes' rule of signs, how many positive, how many negative are possible, find the roots. And it does ask you to do a quick little sketch. So basically you just throw the zeros on there and then just make sure your end behavior is correct. And then we had done one yesterday as well, where you're dividing by a root that is imaginary. So then you would just have to make sure that you include the conjugate as well. So if I say like, this is divisible by 12i, you would say, oh, it's also divisible by negative 12i. So you kind of just do it in 2 steps. And that's it. We're not trying to kill you with just like pure problems. I know sometimes we do that other times. But on quizzes, I really do try to make it so it's doable and you don't have a heart attack and you do have time to just prove that you know what you're doing. So you should have plenty of time, hopefully. Is there anything that people think they would like to go over or that you had specific questions about in regards to good old polynomials? No? Okay. That's exciting. Yeah.
I forget exactly which one it was, but on the little packet thing the other day, there was one that was kind of confusing.
Which
it
one?
was
That's fine. I have packets of the laws over there.
Number 14.
What packet are we on? Because I just got packets.
It's the one that was due so much recently.
Okay, that one. I got
Oh,
some.
was that the one that didn't factor through all the way?
Yeah, like it was like.
Yeah, I got like x squared plus x plus 2 as like a final thing for,
Hold on. 'Cause I actually have
Can
it.
it also be the zero of the function?
Okay, give me 1 second. What number was it? Oh, this is.
14. Sorry.
No, that's fine. I'm just I have my brain is hold on to things. Number 14.
Did you go through and solve that one?
I tried.
So, well, we have just like tried to plug it in, because that's what I did. but
The
then-
one that says a fourth degree polynomial.
Yeah.
Is that one?
Yeah. Or is there like a trick?
You don't have to do any of that. Okay, this is just a reasoning problem. Sometimes we just go into it. Okay, so ready? Think about it. A fourth degree polynomial function has zeros at 3 and 5 minus I. Okay, exciting stuff. Can 4 plus I also be a zero of the function? So one, I need to remind myself this is a fourth degree. What was it? 4 plus I. The answer is no. Fourth degree means there's 4 roots, right? This is 1 root. This is 2 roots. If this is a root, this is automatically a root, right? And this cannot be a root because with this comes this. So that ends up being 5 roots. So that is why it could not be a fourth degree polynomial. So that's all you really have to say. It was just a conjugate theorem, kind of reasoning question. What?
I just said no because I was like, oh, maybe they got confused and did 4 accidentally instead of 5.
No, it wasn't the one.
I thought it was like,
It was reasoning.
I thought it was like the ones
That-
that like the people would.
No, is if you have that, you automatically have that. And then if they're asking this, well, then you automatically put this, and then there's 5 roots, but fourth degree would only be up to 4 roots. So it was just kind of a tricky worded one. But yeah, you didn't actually have to like multiply anything out or do anything like that. You would just literally say no, because then you would have 5 roots. Oh, that's kind of not that bad. Just trying to think if there's anything else in here. We just did a bunch of these. I'll post this in the second answer key one. That's just on my other computer before. I Google. I don't think there's anything to do. Once again, we're not trying to like trick you. Excuse me, I'm not trying to pay attention that one day for 3 seconds and I said this for anything. No, it's all pretty much stuff that we've done multiple problems of. And you can use your notes, but once again, we know with number quizzes, it's key to come in semi-prepared and like know where things are. Just so you're not flipping through pages.
Camera's on?
Yeah, camera's on. Yeah, camera's on. You got it. So does anyone right now have any other questions? We also have tomorrow if you have questions as well. So if you're like going through and organizing stuff and you see something tomorrow in the morning, we can go over that. Or I can always just like send you a little vid if you have a question. But do you guys think that there's anything else that you have questions on? Again, I feel like we did a